Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 6.2 of our virtual geometry text on similarity. We're going to be looking at how to determine if polygons are similar. We're going to be looking for the scale factor and also how to find a variable given two polygons that are similar. If this sounds like what you're looking for, don't forget to hit the like and subscribe buttons, and feel free to visit our website at mathgotserved.com, where you can gain access to our entire collection of Algebra 1, Geometry, Algebra 2, Pre-Calc, and Calculus courses. You can also get the links in the description below. And don't forget, we have 5 practice problems for you to try out in order to demonstrate mastery of the contents of this presentation. Alrighty, let's take a look at question number 1. In question number 1, we have these two rectangles here, and we're to determine if they are similar. Okay. All right. So if we want to determine if the two polygons in number 1 are similar, basically corresponding sides have to be in proportion. Okay. So if we take a ratio of corresponding sides, they must always be the same. So the formula that we're going to be using for this, let's write down the formula. So let's say we're comparing the big to the small. We call this side, let's say this side is A, and this is B. And then over here we have X, and this is Y. So what you have is that side A and side X are corresponding sides. Okay. And then side B and Y are also corresponding sides. So if we divide A and X and B and Y and get the same answer, then the two polygons are similar. If not, then they are not. All right, so basically similar, let's change the color here. Similar if A over X, okay, the left side is equal to B over Y, the tops. All right, they are equal to the same number, then that means that they're similar. Okay, if not, then they're not. All right, so let's go ahead and do that. So we have A over X is going to be, so A over X is the ratio of the left side of the two rectangles, so that's going to be 12 over 8. If we simplify this completely, the GCF here is 4, so divide top and bottom by 4. And then you get 12 divided by 4 is 3. 8 divided by 4 is 2. So 3 over 2, or 1.5. Okay. And then let's look at the ratio of the top and of the top for both rectangles. So we're looking at B over Y, the tops. So that's going to be 30 over 20. Now if we divide this and we get the same answer as the ratio of the left sides, then they're similar. Okay, so let's see what happens here. The zeros divide out, so you have 3 over 2, which is equal to 1.5. Ladies and gentlemen, these two are equal to one another, so check. So these two polygons are similar. Bam. All right, let's take a look at question number 2. All right, so let's say the assumption here is that these two quadrilaterals are parallelograms. Okay, so the question is, are they similar? So we're going to follow exactly the same pattern. All right, corresponding sides, this side right here corresponds to this side, so let's call this side A. This is A, B on the bigger figure, and then this is XY on the smaller one. Okay, so for the other side, the top side, this side and this side are corresponding sides, they match each other. All right, so we already know what the formula is. It's A over X, the ratio of the left sides, is equal to B over Y, the ratio of the tops. So let's do it. So A over X, the ratio of the left side of a parallelogram, is going to be 16 over 12. Okay, 16 from this one and 12 from this. Let's reduce that by dividing by the GCF, which is 4. Divide by 4, divide by 4. And that reduces to 4 over 3. Okay? All right, and then if you want to write that in decimal form, 4 over 3 is 1.3 repeating. Okay, how about the ratio of the tops? B over X. I'm sorry, B over Y. All right, what's the ratio of B over Y? If we get 4 over 3 or 1.3 repeating, then we know they're similar. If not, then they are not similar. B over Y, we have 20 divided by 15. To simplify this, we could divide by the GCF, which is 5. So divide by 5, top and bottom. Okay. And then what do you get? 20 divided by 5 is 4. 15 divided by 5 is 3. 4 over 3 is the same thing as 1.3 repeating. These two are equal to each other, so that tells us that they are similar. Okay? So for number 2, the two parallelograms are similar, basically telling us that corresponding sides are in proportion. All right, let's take a look at one more example on determining if two polygons are similar, then we'll move on to scale factor. So are these two figures similar? This one is slightly different because here we have trapezoids, okay? So we have 3 side lengths that are of different measures. So let's go ahead and label it. So this side right here corresponds to this side. Well, let's say this side corresponds to this side right here. And then this side corresponds to that side. So the bottom, the left, and the top. And then this side right here corresponds to that side right there. All right, my squiggly lines I'm using them to indicate correspondence. All right. Okay, so from the big one, this is A, B, C. Alrighty, and then on the small one we have X, Y, Z. Now when we divide corresponding sides, if we get the same answer for all 3, then these two figures are similar. So the assumption here is that it's an isosceles trapezoid. So let me mark it so that you can see. So we don't have to bother about this side because they're congruent. Okay, so we're going to be comparing the bottom, A divided by X, the ratio of the bottom, the ratio of the left side, B divided by Y, and then the ratio of the top, Z divided, I'm going backwards now, C divided by Z. Alright, so let's do the first one, the ratio of the bottom. We have 24 divided by 12, which is 2. Nice round whole answer. B over Y, we have 8 divided by 5. This is not 2. If we write this as mixed numbers, this is going to be 1/3. Alrighty, so we can clearly see that we're ending up with another answer right here. So it's 1/3 or 1.6, and we can clearly see that these two answers are not the same. So that automatically means that they're not similar. So let's just do the third one. Okay, so C over Z. Well, it's not necessary since they're already not equal. Okay. So C over Z, let's just do just for kicks. 16 over 8 is equal to 2. All 3 must match. All right. So since these two are different, the ratio of B over Y is different from the ratio of A over X, the bottoms and the tops. That automatically means that the polygons are not similar. Polygons are not similar. Had it been the side that measures 5, had it been this were like 4, then they'll be similar because 8 over 4 is going to be 2. All right, so just remember all the sides, all corresponding sides, the ratio of corresponding sides must be equal in order to establish that the polygons are similar. Okay, so the next example we're going to look at, question number 4, it has to do with scale factor. So we're to find the scale factor of the smaller figure to the bigger one given the fact that they're similar. So the assumption here is that these two rectangles are similar. Okay, so scale factor is pretty straightforward. All you just need to do is find a pair of corresponding sides. So on the right side we have these two sides are corresponding. Okay, on the short sides of the rectangle. I'm choosing these right sides because these are the sides that I know what the value of the measure is. This is our small and this is our big. So to find the ratio, the scale factor, let's write down what the formula is. Scale factor is equal to so we're doing small to big, so here is going to be small side length divided by, that's not going straight, small side length divided by what? What are we going to be dividing by? Small side length divided by corresponding big side length. We're using big and small. Okay, so small side length divided by corresponding, I'm going to write it for short, big side length. You just need two numbers and you're good to go. All right, so in this particular case we're looking at, let's call this A, and let's call this B. So we're looking at the ratio of small to big. Small to big. So in this case, it's going to be A over B. No, you know what? Let's not use B. Let's use X so that it's the same across all of them. So A over X. All right, so that's what we're going to do. Just divide 20 by 24. Okay, so let's go. So the scale factor is going to be 20 divided by 24, written as a fraction, 20 divided by 24. And then this can be simplified. Okay, let's simplify this. So you divide by, what goes into 20? What is the biggest number that goes into 20 and 24? It's 4, right? So 20 goes here, 4. 20 goes in 20 divided by 4, 24 divided by 4. So that's going to give us 5 over 6. Okay, so the scale factor in fraction form is 5 over 6. You can write it as a fraction, you can write it as a ratio, and then you can also write it as a decimal. All right, so the scale factor in fraction form is 5 over 6. As a ratio, guess what it is? As a ratio is 5 to 6. All right, top to bottom. As a decimal, all you just have to do is use your calculator and divide that out, or you could use long division and you're gonna get the same thing. All right, so let's look at what that is. If you divide that out in decimal form, it's going to be 0.83 repeating. Okay, so these are the 3 different ways that you can express the scale factor of the smaller polygon to the bigger one. All right, let's take a look at our last example, question number 5, and then we're going to give you some practice problems to try out to demonstrate mastery of the contents of this presentation. Okay, so these two figures, these two polygons are similar. So we're going to use that fact to figure out what x is. All right, so this side corresponds to this side right here, and then this side corresponds to that side right there. So this is AB and this is XY. All right, so since these two polygons are similar, we can set up the ratio of corresponding sides being equal. Okay, so the bottom, a of the big divided by x, the bottom of the small, is equal to the ratio of the right side, b of the big divided by the ratio of the right side, y of the small. Okay, so these are corresponding sides. So a over b is equal to b over y since they are similar. Okay, all right. So now that we've set up this proportion, we are going to substitute and use the appropriate algebraic procedure to finish it up. Okay, so a is 4x minus 9 over x is 14. That is equal to 15. That's b over 6. All right, so how do we solve this resulting equation? This is known as a proportion. All right, we can solve this using the butterfly method, okay, or just cross multiply. So you multiply 14 and 15, and then you multiply quantity 4x minus 9 and 6. If you carry out that multiplication, you are going to get, now be careful here because your numerator on the left has two terms, so you have to group it in parentheses. 4x minus 9 times 6 is equal to 14 times 15. Okay. All right, so let's go ahead and multiply this out. On the left side, we're going to distribute the 6 across 9 and 4x. So if we do that multiplication, we're going to have 24x minus 54 is equal to, and then 14 times 15 is 210. Alrighty, so now we're going to solve this resulting linear algebra equation with one variable by adding 54 to both sides and then dividing by 24. Alrighty, so add 54 to both sides, and then that's going to give us what? What is that going to give us? We're going to have 24x is equal to 264. To finish this off, we're just simply going to divide both sides of our equation by the coefficient of x, which is 24. So divide by 24, divide by 24, and your answer, x, is going to be equal to 11. All right? So that's the solution to question number 5. Now it's your turn to try out some practice problems to see if you've mastered the contents of this presentation. Alrighty, ladies and gentlemen, here are the 5 practice problems that we would like you to try out in order to demonstrate mastery of this tutorial. So 1 and 2, you have to determine if the polygons are similar. 3 and 4, you have to find the scale factors. And then 5, you have to solve for x. So go ahead and pause the video presentation at this time and try out the 5 problems. When you're done, click on the playback button to reveal what the answers are. Welcome back. Hopefully you had a chance to try out these practice problems. Let's take a look at what the solutions are. So question number 1, are the polygons similar? The answer is yes, they are similar. For number 2, they are not similar. For question number 3, scale factor for this, the ratio of the smaller to the bigger, you can write it as a fraction, which is 1 over 2, or you can write it as a ratio 1 to 2, or as a decimal 0.5. For number 4, what's the scale factor here? Let's take a look at the answer. In fraction form, the scale factor is 3 over 5. Or you can write it in ratio format, which is 3 to 5, or as a decimal 0.6. So there goes your scale factor. And then number 5, what is the value of x? Given that the given figures are similar, for number 5, your answer x is equal to 10. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of similarity, do give us a like or thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to other presentations such as this. To gain access to a wide variety of support resources for geometry and other courses, visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.